All right, guys, real quick, just talking about the graphs that you made for the hydrogen lab. So you had two different graphs you were supposed to make. Both should have been line graphs with connected dots. Your first graph, what you were really looking at, remember, we should be able to title graphs. Um, the first graph was really about the effect of the volume of acid for HCl and the volume of hydrogen gas produced. And your IV, so that's what goes across the bottom here, is going to be your volume of hydrochloric acid. And we measured that in milliliters. And then your dependent variable was the volume of hydrogen gas, and that was measured. Really, what we ended up measuring was the circumference of the balloon, so that was centimeters. Now, you need to set up your scales, and you should have a consistent interval across both your x and y axis, so make sure every box has the same value as you go left to right, and then every box has the same value as you go up and down. And then this corner right here is going to have to be 0 value on your x-axis and 0 value on your y-axis. Now, for this first graph, you should see that initially you have a rise in the size of the balloon as the volume of hydrochloric acid increases, and that you should continue to see that a little bit out to kind of like a first couple data points. But then it flattens out, and that balloon stops getting bigger even though we're adding more hydrochloric acid. So it's worth kind of considering, well, what would cause this? Why would we initially see that there's a direct relationship? More volume of hydrochloric acid caused a bigger balloon. But then we see that direct relationship stops, and as we continue to add more hydrochloric acid, the balloon stops getting bigger. And the reasoning for this is kind of, we talked about chemical reactions and we compared them to s'mores the day that we did the lab, making s'mores. In this case, having more hydrochloric acid is not going to help us make more hydrogen gas, because hydrochloric acid isn't what we've run out of. When we got to this point here, we've used up all of our zinc by that point, so more hydrochloric acid was just going to be extra stuff left over. What we really needed in order to keep making a bigger balloon was more zinc. So in this section, we're adding more of an ingredient we already have too much of or left over anyway, so that's not really helping us out. So that's kind of something to consider when you look at this graph. Now, the second graph, in this case, for the second graph is graph number 2, what we were looking at was the mass of zinc that we changed, and that was in grams. And then that caused the hydrogen gas volume, sorry, I'm putting that in there wrong, the volume of hydrogen gas, which, again, we measured the circumference of the balloon, so it was really a measurement in centimeters. We looked at how that was impacted. And so our title would be the effect of the mass of zinc on the volume of hydrogen gas produced. In this case, you saw a consistent increase that kind of looked like this. Between your 3 data points, that as we added more and more zinc, the balloon kept getting bigger. Now, if you think about this particular experiment, the second experiment, you always had 100 milliliters of hydrochloric acid used. So you had lots of hydrochloric acid. And so when we only had 3 grams of zinc here, we got a small balloon and we had hydrochloric acid left over. And then when we had 5 grams of zinc, we had a bigger balloon, so we increased the size of the balloon, and we still had hydrochloric acid left over. So when we added more zinc, the balloon got bigger, and we still had hydrochloric acid left over. Eventually, if we kept adding more and more and more zinc, we would eventually reach a spot where adding more zinc stopped causing the balloon to get bigger, and we would have this flat horizontal line. When that happens, it means we've used up all the hydrochloric acid, and more zinc is not helping us make more hydrogen gas. It's like using up all your marshmallows, adding more chocolate is not going to help you make more s'mores. Once you run out of that ingredient, that's the thing that you need to replace in order to keep getting more s'mores, or in this case, more hydrogen gas being produced. So, from a real quick basic look, that's what your graphs should have looked like, and kind of why you're seeing what you see in potentially a flat spot being produced where you're no longer seeing that direct relationship. All right, if you have any questions, make sure you touch base with me. Otherwise, have a good one.